So, yesterday, I did not do my cardio until here. Just up there. Which means this got fucked up on my sleep. I didn't get to bed until like 8:39. This thing, afternoon stream. Can I just move it like that? No, it's not gonna want to do that. 1 a.m. needs to be p.m. This turned into wasted time. I basically got some food in me and just like I just like wasted a bunch of time. So this is another missed opportunity to do stuff. Cross. Okay. Bam. And then I'll do the same thing here. Just say, please edit wasted time. So I'm starting to notice a pattern here. The past 2 days, wasted time missed stream, wasted time missed stream. I'll just extend this out to 4 because I think pretty much the entire time I wasted. Yesterday I did get a stream in the morning, morning into afternoon. That was productive. I got all my taxes stuff over to my accountant. I handled all the social stuff I needed to do. Part of that was the reason why I canceled the stream in the evening and went to dinner with some friends, because I kind of was like fucking up and ignoring spending time with friends. So I don't think that was a bad use of time. I enjoyed hanging out with people last night, but pretty much after the stream in the morning, I was gonna go do some cardio and then hop right back on to do some more work. That is where I kind of like fell into this YouTube rabbit hole. And it's definitely YouTube. YouTube is like my major problem. The problem I have with YouTube is it's kind of like nutrition, where people who have behavioral issues around nutrition, like consuming too many calories, they have a bit of a problem that a lot of people don't have when it comes to addiction, and that you have to eat in order to live. Not only does your body just force you, like, not force you, but your body really pushes you to consume calories, because evolutionarily that was advantageous, but you actually do have to consume calories to live. And so what we all have to do to have a healthy relationship with calories is we have to develop the appropriate safeguards and behavioral controls around how many calories we consume and what calories we consume. And we refer to that as a diet. And when it comes to YouTube, I feel like it's somewhat similar in that you cannot not use YouTube. I've tried it. I've tried blocking YouTube entirely. And not only is it socially difficult, because people will send you links to things, and if you just say, I can't watch this video that you sent me, I mean, some people will like screen capture it or screen record it and send it to you, but most people will just be like, okay, or possibly interpret that as you being like not wanting to engage with them. So I think direct linking to a resource on YouTube for social reasons is something that is appropriate. I don't think that's an unhealthy thing. The problem is once you've entered into the YouTube app or the YouTube website, because I don't even have the app installed. It's mainly the website for me. Once you've entered into that website or the app, now the YouTube software is pumping you full of other things. It's like, oh, you watch this video, maybe you want to watch this one. Here's a bunch of like stuff that taps into your mammalian or your reptilian brain, your prefrontal cortex or whatever it's called, the part of your brain that is wired to just respond viscerally and emotionally to things. All the content on YouTube, the thumbnails, the titles, like so and so destroys so and so, and like here's a picture of a woman's ass, and here's a fucking some gross thing that, like, it's like no one in their right mind would choose willingly to consume any of this stuff. But because it's being force fed to you by like this AI algorithm, and it taps into a part of our minds that evolutionarily like adapted to a world like possibly, you know, several hundred millions of years ago, a world of like scarce resources, of like fear of predation, of, you know, desire for sexual reproduction, you know, pushing us to reproduce, like all of these instinctual, innate, deep in the brainstem of like chimpanzees, you know, like all this stuff that like was baked into our firmware as primates. It hasn't, and it will never adapt to without heavy like AI enhancement. Like our brains, our reptilian minds will not adapt towards these new systems that are taking advantage of us. And that leads to like this cascade of like dopamine release and other hormones and neurotransmitters that keep us behaviorally locked into using their software, because in doing so, well, I pay for YouTube Premium so I don't see ads, but in doing so they generate an incredible amount of ad revenue, and of course they are able to monetize through Premium as well. So it's just in their financial interest to keep you locked in, engaged, doing stuff, even though you don't want that. And I hear this argument all the time from people online. It's like, well, they're just giving people what they want. Well, people want things at different levels of their minds. People aspire to achieve and accomplish things outside of basal drives, you know, outside of consumption. And like these things are in tension in every person. And like I have these things that I want to accomplish, like right in front of me. Like there's so many things that I want to accomplish, and yet I am spending time on these apps consuming mindlessly, nearly mindlessly. I mean, sometimes, you know, I go on there for this channel that I found recently, the Math Sorcerer. I love him. It's super motivating, and he's kind of like the David Goggins of like mathematics. But he makes some of these things like super approachable. He of course is, you know, he makes a living off, I believe he makes a living off of some form of living off of selling books and instruction on online. But he did recommend a book, the How to Prove It book, that I went over yesterday. And I think he's a good resource for me. So like there are good things. YouTube is not all negative, which is why it's so difficult to deal with. If something's all negative, like TikTok, I can easily just ban TikTok from my network. I've never had a problem with TikTok. Never. I've never installed the app. People sometimes would send me things and I would click on them and it would send me to the website. And then immediately, you know, they start pumping you full of videos, and immediately I can recognize, okay, this is like problematic. And so I just close it out. Or like more recently, you know, I've just blocked it from my networks. So if someone sends me a TikTok link, I can't view that, because TikTok is crack cocaine of like information. Like it's so easy to recognize. Whereas YouTube is more like, again, like this dietary analogy that I like to use. And so it's very difficult for me to maintain a healthy relationship with YouTube when they start introducing some of that crack cocaine stuff. They start introducing YouTube Shorts, or they have an algorithmic feed that puts stuff into your queue for you to like watch, and you just scroll. It's at the endless scroll. I think endless scroll is the worst pattern for human beings on the internet. It is a powerful invention that has been used to manipulate and control human beings' behavior for the net negative. I cannot tell you a single, I'm not a UX person, but I cannot tell you a single application I've used where infinite scrolling has led to me being more productive, more satisfied, more accomplished, more developed intellectually and academically, having a better understanding of the world, just feeling more overall satisfied in my life. Every single time I encounter infinite scroll, it is because they're trying to keep me locked into an app longer than I otherwise would have preferred to be. So, I don't know, there's a lot of these like dark patterns. I consider infinite scroll a dark pattern. But yeah, the YouTube app pumps you full of this infinite scroll, and it's a slot machine. Basically, they've created a digital slot machine, which is insane because like I enter a casino. I've entered a casino a few times in my life, and I look at the slot machines. I played them a couple times. Actually, the couple of times that I did play them, I won, and then as soon as I won, I just left because that is if you win early at a slot machine, that is the only time really that you're gonna be able to get out of there without losing money. Because the more you stay there, the more you play, the more money you lose, and they know that. But I look at the people playing slot machines endlessly. I'm like, oh, these fucking dopamine fiends. I feel so sad for them because like they're just being taken advantage of. I remember hearing a story a long time ago. I think it was on NPR about a woman, I think it was, that had Parkinson's, unfortunately. And Parkinson's is a illness, from what I understand, of dopamine. Dopamine is somehow in the causal path of like what causes the symptoms of Parkinson's. It's like a inability to regulate dopamine or something like that. And so some of the therapies for Parkinson's, while they work, they help the person regulate dopamine. One of the side effects is that they're predisposed to addictive behaviors because of the dopamine. And this person went into a casino and was on these Parkinson's drugs and just got addicted to gambling, mainly slot machines, and just I forget if it was a woman or a man, but basically just lost their life savings gambling, mostly from slot machines. So like these things, like these are systems. Like, who creates a slot machine and is like, I've made the world a better place? Like the slot machine is not a good thing, demonstrably. I think people should have the right and the freedom to do whatever they want with their lives. And if they choose to use slot machines, especially in a healthy way, like just for entertainment temporarily, then that is on them. But really, you're playing with fire, you know. I don't think people should be deprived the ability to choose to do that, though. But at the same time, the person who created the slot machine, I don't understand how they can sleep at night. I mean, they probably have like, you know, hundreds of millions of dollars, so they're probably sleeping pretty well on their stack of cash. But like, I don't think doing something like that with your life, knowing that it's causing suffering of others and the ruin of others, even if they're a small portion of people on this planet, I feel like, how do you do that? The financial incentive, like, is so insane that it would drive people to do something so net negative with their lives. Like, you're making the world a worse place. And it's the same thing with these applications. The incentives are structured in such a way that they're virtually creating slot machines for people to just toil away and waste their lives on. And that's something that, I want to work on. I started this project at the end of last year, this media proxy project, and I made some progress on it, but not much. What I've focused on since the new year is focusing on actually getting stuff done. And in doing so and wanting to get stuff done, I am less tempted by these apps. But I do find myself during downtime, like during meals especially, reaching for YouTube. Not because I want the crack cocaine content that's on there, the YouTube shorts. The YouTube shorts are so idiotic. Like, let me just pull it up right now. Okay. Let's go here. So I just went to my homepage. Okay. So there's two things that are programming related. One is the Primogen, which say what you say about his content, at least it's programming related. And the other one is Coding Jesus. He was surprisingly ready for this. Hardest question yet. And okay, those are like benign, slightly positive, maybe impact on my life. But then right below that is like a woman's ass, and it says, "Why Joe Rogan hates beach houses," and it's a picture of a beach house with a woman in a bikini. And then it says on the thumbnail, "Stupid Viral Academy." It's like, yeah, you're stupid if you click on that. Like, it's just tapping into your fucking monkey brain. And then some political thing, like, okay. And now I go down to the next section of shorts. Something about Nazis. Not sure why that's on my feed. It's like they're just like whatever taps into that like fear, primal instinct thing. Like they throw up onto your feed to try to get you click. There's a Dune thing. There is a Jonathan Blow video, which I actually do like his stuff. And then there's some video about ducklings. One of his ducklings got left behind by the mother and it had to like paddle up a stream. It's like, what the fuck are we doing here? Like, why do I need to watch a video about a duckling in danger? Mother refuses to abandon baby and jumps down to help. I get a lot of these wildlife and animal distress videos, and I try not to click on them. Like I care about animals, but I try not to click on them because there's a certain percentage of these videos that are staged, and that is the most fucked up thing I can imagine. Is people who put animals in harm's way to stage animal distress so that they can rescue the animal and get a bunch of fucking views on YouTube. Like, how disgusting is that? And that happens. It's not, I'm not saying all these videos are like that. Like, some of these are genuinely good videos of people helping animals, but some of them, some percentage of them, and it's getting increasingly harder to tell which ones are which, are people deliberately putting animals in harm's way, sometimes even harming animals, just to make money on YouTube. It's so fucked up. Another video on math for machine learning. So again, you can see how it's like mixture of like things that make your life better and things that demonstrably detract from your life and cause you to waste time. Jamie Dimon video. I don't really give a shit about Jamie Dimon. How to remove a fence in 4 minutes without digging. Who gives a shit? Why am I watching this? Stephen Mold, which I actually like his channel. I think he's a great guy. I think I bought one of his. No, that was a different creator. Anyways, video from him. Another math video. Someone's dog at the beach. Happy Sunday from Coda. I don't even know. I don't follow this person. Why am I looking at their dog? There's one thing I kept on getting in my feed. Maybe if I scroll here, I can find it. Because they keep on putting it in my feed. Is this woman who's pregnant. I've never subscribed to her channel. It's a woman who's pregnant. And she has her baby, her belly out like this. With like flour or something on her hands. Touching her belly. And it's like, we're expecting. So it's like, I don't know this person. Why is it that I'm being shown, like, I'm not saying it's like suggestive or anything, but I don't give a shit about you and your baby. like I'm happy for you. But this person is not posting that because they're sharing it with their family and friends and loved ones. They're sharing that event with the entire world to try to get engagement and clicks. And it's like, that I just don't understand. And I don't understand why YouTube is pumping it into my feed. I've seen it at least like a dozen times. And I'm like, this woman should not be, well, she can do whatever she wants, but I just don't see why the algorithm is pumping that out. Maybe people engage with it, and good for her, like, that people engage with it. But I just don't see why everyone on the fucking planet needs to know about her and her fucking pregnancy. Like, I mean, mazel tov, you know, I'm happy for you. I don't need to see it like a dozen times in my YouTube. I don't need to see it a single time because I don't know you. I will never meet you. You have no impact on me. I have no impact on you. Like, it's like the most it's the most nutritionally deprived calories that you can possibly consume. That's what you're doing when you're consuming stuff like that. And yet YouTube's just pumping it into the feed. Movie or a video about the Goonies, behind the scenes. Oh no, this is an AI one where they take the actors when they're young and then when they're older and they have them interact with each other. It's actually really great. Really amazing technology that they could do something like that. But again, like, it's like so much of waste time. And then a 3 blue 1 brown video, which I actually really like his stuff. Another Primeagen video, another wildlife video. This prop hunting guy. I've watched so many, probably hours at this point, of this prop hunting guy's YouTube shorts. I mean, it's an interesting game. Like, you're disguised as a prop, and you have to like kind of like put the prop in the scene, and then people go around and like shoot the different like things in the scene to try to like figure out who's a prop, and then you have to run away from people if they discover you. But like, did I need to spend several hours of my life in the past 3 months watching his shit? No. Like, I would have been better off just like staring at a white wall. Like, I've done that before. I stared at a white wall, and like after 10, 15, 20 minutes of doing that, like, your brain is just like in such a better state, like a more healthy state to be able to like just think clearly. It's kind of like sensory deprivation. But like, that would have been, staring at a white wall would literally have been better than spending hours watching this prop hunter guy. And again, it's infinite scroll, infinite scroll. You keep on scrolling, you get more and more and more. Chris Kattan. I don't even know why, but like recently I thought about Chris Kattan. Um, oh, it was some video I was watching yesterday where it was like, uh, there's these two guys. They're like film buffs, and they make these little puzzles for each other, and they'll like show like the just like the eyes of an actor, and you have to tell who it is. And like the clue is like all of these actors' name is Chris or something like that. Um, and so Chris Kattan popped into my head, and now the feed has Chris Kattan in it. And maybe that's just me like noticing it because I thought of him the other day because of YouTube. But part of me is like, does the algorithm really know what's going on in my head? Like that I thought, like I didn't indicate in any way that I was thinking about Chris Kattan. But then like Chris Kattan, who like is not in popular media really at all, like pops into my feed. And it's a 6-year-old video. Like, how did YouTube know that? How is the algorithm so like tapped into my freaking brain? Like it has its little spidery fingers stuck in my skull that it knows my inner thoughts. Like that is fucking scary. I think what is needed here is like really healthy distancing with YouTube. And then there's a video about Feynman, which I probably would enjoy. Something about Palestine, which I guess it's important to be informed about what's going on in the world, but I really can't help those people and they can't have an impact on my life. So like, why is it that I need to be presented with all this graphic shit? Like, okay, now a video of a fox stuck in a chain link fence. Something about cryptography. A video, I've seen a lot of these recently, is videos of cats wearing cameras on their collars and then going around neighborhoods and interacting with other cats and other animals and other people. And it's like, why am I watching this? I would say the value that I get out of YouTube is more than massively dwarfed by the subtraction it has on my life. There's the addition component, and then there's a subtraction component. And the subtraction is just dwarfs the addition component. And it really has to do with like these anti-patterns of infinite scroll, of YouTube shorts, of high dopamine, random periodic reward, and keeping you like away from the reward. Like if the app just like blasted your dopamine constantly, like you wouldn't continue to use it. Like you would burn out on it. So what they do is they space the reward randomly, and that's really what gets you addicted. It's like, oh, there could be a reward there. I need to check. And it comes again back to the algorithms that are baked into our firmware of foraging and scavenging for resources. And this is in every animal conceivable where you get that release of dopamine whenever you discover a random reward, and the more random seemingly the better for keeping you addicted, because you got a reward from like opening this box at one point, then just randomly in your head when you're doing something else, it's gonna pop in your head, oh, what about that box over there? It gave you a reward one time, let's go ahead and check on it. And so you open it up, not a reward this time. You close it, and then you go on with your time, and then you come back later, let's say, oh, what about that box? And you open it up again, it's a reward this time. And the periodically spaced random rewards just keep you in this behavioral straitjacket where they could just keep you right there, just addicted to using their apps because it serves their financial interests. It is the most perverse evil. I would categorize the evil thing that a person could do. An engineer, a product designer, a product manager, it's the most evil thing that you could do is to work against your users causing them to be addicted knowingly. And then instead of working to the betterment of your users, you just say, fuck the users. Fuck the users. We're going to take as much value from their lives as possible and enrich ourselves. That is an evil thing to do. I know this is a bit of a rant, but I'm reflecting on the past 2 days of just wasted time in my life. And it was quite a lot. Friday, pretty much the entire afternoon into the evening, wasted. Saturday, morning session, afternoon session, wasted. And so I'm talking about all this stuff just because it's been on my mind. I've had a pretty successful week of like consistently studying, really not wasting a lot of time. I had a nap, which I don't really consider wasting time, but like it's like not a great thing to just nap in the middle of the day. And then I had, outside of Saturday and Friday, I had 2 time wasting sessions in the morning. So today I'm going to mark this stream as 7 a.m. to 8 a.m. This is my morning rant stream. Let me put a little check mark here because I did show up for this one. Check mark button. Bam. This event. Update. What is this thing? I didn't do that at all. You can go away. Thank you. This event. And then I woke up at 6. I slept in here. I just let my alarm go off for like an hour. And then this was all waste time. Time wasted. Brown. Save. So I did this morning waste a little bit of time. Part of that was YouTube. Most of it was YouTube. So, I mean, I'm streaming live onto YouTube now. So, and these live streams, I mean, I think I get most engagement on Twitch, but these live streams, I get a lot of value of whether it's Twitch or YouTube. But I've questioned and I've tempted several times whether I should even have YouTube in my life. And I think what I really want, if I could just snap my fingers and have accomplished this, is I want a network proxy that can man in the middle the connection with YouTube and just regulate my access to YouTube using whatever AI or whatever features. Basically, like, YouTube has an incredible AI machine learning infrastructure pointed at my prefrontal cortex, or whatever they call it, amygdala system. What is the reptilian brain called? Basal? No, it's not. Amygdala. That's what I've heard it. The limbic system. Anyways, I'm not a freaking neuroscientist. They have this AI machine learning system just pointed straight at your reptilian brain, manipulating you. And what you really need is to have a system in front of that defending you against all of that shit. So I started working on that. That was the media proxy project that I was... Well, come on, what are you doing here? Do I still have that? It's not pinned, but it should be here somewhere. No? Maybe I never published it. Interesting. 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 Anyways, I did start working on that. There is a repo on my computer here, pretty sure. Jump to media proxy. Yeah. I just haven't published it yet. And it's meant for like a cloud deployment. Trying to think, like I could spin this thing up and just do all the things that I want to do. But I think when I was working on this, I had this tension between like doing the thing I want to do and doing the thing that could potentially build something that can be productized. And I think the realization I'm coming to is with this project, I just need to build the thing that I want. Even if it's like not, it's like a legal gray area. Like what I really want is a complete proxy in between me and YouTube where everything goes into it. It does caching, it does anonymization, privacy stuff. It does like downloading of the YouTube videos for better streaming locally. Because a lot of times like you'll connect to YouTube and then like say you're on mobile and you'll like lose your connection. So it'd be really nice if the web app would fetch the content, like the entire video, into memory, or as much as possible into memory or some type of local storage, so that when you have these periodic service interruptions, you can have the video locally, stored locally, which YouTube doesn't want you to do for obvious reasons. They want to keep everything streaming from their servers. Something that gives you, privacy in that it's not actually running the YouTube application or the web application. It's talking directly to their backend systems, downloading the video for you, and presenting it to you in a way that's privacy respecting. Anonymizing your IP address. I do think there is a lot of value in some of the signed in experience, like history. But history is like fucking broken on YouTube. Like you have to sign up for all this other bullshit in order to get history. And sometimes history is just like fucking broken. So history might even be a feature that I could like rebuild. But like the main thing is like performance, privacy. Those are the two things: performance, privacy, and above all those is elimination of all these dark patterns of infinite scroll, of algorithmic feeds, of grazing. I call it grazing. No more grazing for information. Yeah. So I guess if I did take on this project again, which I don't really have a lot of time, as you can see, like my learning objectives are going to be consuming most of my time for the rest of the year. But if I did take that on again, I think I would approach it from just doing the thing that I want, and less doing a thing that I could potentially turn into a business, which is the way I was approaching it before. Anyways, that's enough ranting about YouTube. Let's do some planning. So we got 3 sessions today. I'm going to break for breakfast, lunch, and cardio, and dinner. I might need to do some grocery shopping here because I've been unable to get to the grocery store. I do have a bunch of chicken breasts and lipids, fats. So protein and fat I'm pretty good on, but carbohydrates right now, the only carbs I have are like oatmeal, like steel cut oats, and rice. And I do have a rice cooker. I could cook up some rice, but maybe I just do that. Yeah, we'll see. But yeah, I have my meals planned out here. What do I want to accomplish today? So I have all these things that I'm currently working on. I think the highest order bit for me right now is to finish the cache lab the cache simulator I've been working on. I got it to pretty good states. It was passing, I think, like 7 out of 9 tests. It's not perfect, and I wanted to refactor it at some point to use less memory, but just as an exercise to make it to where its memory accesses are contiguous instead of just pointing to random areas that have been allocated, like doing one allocation up front of a contiguous amount of memory and then just accessing that memory. I think it would be nice to go through that exercise of taking the object-oriented approach where you're doing all these allocations, all these different random parts of memory, and then turning that into a single allocation where the memory, the data structures are mapped onto that single allocation. It is kind of complex because it's like you have these headers and then you have a variable length arrays, and then you have headers inside the elements of those variable length arrays, and it's kind of like a nesting thing. So you kind of have to like compute the size of the headers and math out the dynamically sized arrays as well, starting from like the lowest components, like the cache line itself, up to the whole cache itself. So doing that computation, I could probably write a method on the cache to just do that computation and do the allocation. So that'd be like fun refactor to do. But I did want to get the lab done first before I do that, so I can consider once the lab is done, do I want to do that exercise or not? So I think that's what's going to be my focus for today, is the cache lab. So let's poke around here. I think this is another project I was going to start working on, which is to categorize all this Linux syscall table. But this is the cache lab here, and we are, in a pretty good shape here. So this is going to be a difficult one to debug why it's not doing what I want it to do, because this trans trace, basically my hits are under, misses are over, and evictions are over, obviously. So let's open that up. Vim traces trans. So what is unique about these is there's a lot of these instructions which I ignored. So let's go under traces, and we're just gonna rip grep for capital I, and we'll do L. Yeah, so this is the only one with instructions. So I'm pretty sure that the reason why I'm not passing these is because he told me not to just to ignore them as part of this part of the lab. So we're gonna need to implement basically the second part B of the lab. So we're in a pretty good spot passing all the tests for part A. Oh, the other thing is the block size. I didn't consider that. Yeah, I need to fix that. So let's open up, and this might be something that we can test with ref. So I did this one, and then I did mine, and they came out different. Not that one. Ref. So that was 515. I think I was doing 444. Yeah, this one here. And I'll take out the dash V, and we'll do long.trace. And then we'll run it on CSIM myself, and you see they're different results. So I think the issue here is that I believe the issue here is sim. See, is that when I do this, so can I collapse these? No. It's parsing simulation. Here we go. This upsert line. I guess I'm doing it by tag. Huh. I guess that works though, right? So if we go back to our memory layout of this cache, we have our tag bits, we have our set bits, and we have our block bits. And block bits are effectively ignored. We select the appropriate set using set bits. And if we go here to parse adder of cache using adder, when we do this, we should select, or we should print out the result before we return it. So here, printf out and we'll say parse adder, new line, and then this is going to be .tag. It's going to be %d, I believe. This will be a.tag. This guy doesn't need that anymore. Here, and now we can search for tag and replace it with set and replace it with block. Okay. So that should get us that. And we'll do a little makey make. Of course, it's going to be a long. All right. Make and rerun it. What would csim ref here with verbose? What does that do? It prints out the line and says whether it's a hit or miss. So we need to replicate that in r-v. Because what we do is, of course, we do all this. I think it's called printf verbose. Yeah. We'll do that for now. Let's go to all the verbose stuff. And it's all macros. Type adder size. What is this? I think we need that. Okay, we can comment all these for now. Alright, so if we do a make here, and we are under csim-v, it should be pretty much the same output, yep. So what we want is it to have the similar output, and then we'll do a diff. So ref here. So it looks like it prints out the line, and then it prints out a little thing saying miss, evicted, a hit. If it's an M, you can have a double hit. Do I do that here? So that's the record result. Store, if it's modified, what are we doing here? Yeah, if it's a modification, we do a load and store. So you can get a hit there. So if we go up here, what we need to do is print out the line first. So printf verbose. And we're going to print out the line without the new line, hopefully. And this is going to be line. I hope. And then we'll do a makey make. And we'll do that. It does seem to print out the line. The problem is that we also have the hit or miss being printed out. Do these go to like separate file descriptors? If I send 2 to dev null, and then if I send 1 to dev null, no, they're all going to 1. So this printf verbose somehow I gotta get the right. Here, I'll put like a pipes around this. Oops, sorry. Make, run that. Interesting. What the hell is going on? Oh, because the new line's in there. Okay. So the new line is part of the string. We do have a space before it, which is to allow for the instruction thing. Do we have any instructions? No. That's only in the other one. Okay, so we got oops. What's interesting is that they don't have, it looks like they parsed it out and then reprinted it as a separate structure. So I think what I need to do is here is type is going to be a char. The adder will be LLX. The size will be a comma here. And then we're going to print out not a new line. Sorry. Oops. So it's type. So the problem with type is that type is going to be one of these. So we need a little function that converts it in action type char. And it takes in a in action type t, and we'll just call this t, and it returns based on a switch of t, and we'll put all these as cases in that. Bam. Unknown doesn't need to be there. We'll have a default, and then we'll have that, oops, that, and that. Return L. Boom, 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 boom. This will be a store. This will be a modification. This will be an instruction. This will be unknown. Okay. So then down in our printf, down, where is it? Here, we're going to call in action type char of act type, and now it gives back the right character there. Adder and size. So if I do and then I need to also print out in here okay, breakfast starts at 8 a.m. Great. Here is going to have to be our new line. And then I'll just delete all of this here. And then in here, in the loaded stores, we're going to, when we record result, we'll just print out with the space on the left-hand side the result. So here will be printf verbose, and it's going to be some format string. In this case, it'll just be a hit with a space on the left. This will be, why does that not indent? Okay. This will be a miss. And then this will be a miss eviction. Okay. So let's make up this. Oh, we got an error. So line 157. Oh, I need to do cases here. My bad. Case that. Boop, boop, boop. There we go. Let's do a make clean and a make. Looks good. Let's go ahead and run our csim ref and our csim not ref. Looks very similar. Okay. So csim ref, we're going to pipe this into ref.txt. Sorry. And then csim not ref, we'll call test.txt, and we'll delta between ref.txt and test.txt. Okay. So this is very different. It's basically all green and then all. Is that because the memory references are different? No, they're not the same. Let's just do a head here then. This will be a head of ref, and we'll do the head, oops, head of test. Okay, it's because of space. So it looks like they did it a little bit differently, in that theirs kind of is worse, but we'll replicate theirs just to make everyone happy. So we have this here, we'll put a space here, and then when we go into our load store, record results, we'll assume the space is on the left and we'll put a space on our right. Oops. Oops. There we go. We'll say make, we'll re-output our csim, and we'll redo our delta. Look at that. So now if we go back to our delta originally, which was here, okay. So this is where we have, they had a hit and we had a miss eviction. Interesting. We're doing more miss evictions. Quite a lot more. So we need a way of debugging this. It looks like the first one was here, line 3108. So let's look at that trace. So the trace is long. Okay, he's been in here a lot. It could be my eviction policy. Let's look at our eviction logic. So if we had results evicted here, Let's go up here. This is our eviction logic. I guess what we should do is like kill this, do our delta again, and see if, okay, so we had a miss eviction. Was that preceded by another eviction? No, it wasn't. It was just like, okay, you're just not in here. That's fascinating. Because what that means to me is that we evicted what we shouldn't have. And that's the root cause of this whole thing, versus we evicted something that we shouldn't have. We just shouldn't have evicted at all. We should have computed a hit when we computed a miss. That means that our tags would have been aligned correctly. Oh, sorry, our tags would have been equal. Our sets would have been equal. But for some reason, we computed a miss. So I can run this under a debugger and add instrumentation for that, I think. So we're going to say in GDB, I want to break when a function is called with an arg equal to this value. So this would be the second function, or second, so it'd be RSI. Okay, here we go. So we're going to run GDB. Let's run our delta again. So it's not only just that that value exists, because that value has to exist. What is this for again? The size. Oh, we don't even consider the size. We just consider the adder. Well, that's going to be a problem. But that would cause us to have more misses. We assume a single byte, so that's a problem right now. Okay, so this action has a size, and we just pass in the adder. So the type doesn't matter. We do that. We handle the switch there, but we also need to pass in the size here. Okay. So our loads and stores need to handle the size. What is size again? Size is a long? No, it's a size T, obviously. Okay. So we say size TS? No. Size. Size T. Size. Size. Oops. There we go. To do. I think here they say you can assume that it's on a. For this lab, you should assume memory accesses are line properties, such as a single memory access never crosses block boundaries. By making the assumption, you can ignore the request size in the Valgrind traces. We'll say note here. Size can be ignored because the lab said all memory axes are aligned. And never cross block boundaries, which is obviously not true for all cases in general, but you can assume that here. Okay, so the size I can ignore. So I want to set a conditional breakpoint when this is the memory address, but we have a miss when we want to have a hit, which is hard to do because it's like on line 3108. So what I can do is pass that information in. So when we get the line, we can increment a counter here. So we can have an access sequence, which will be just a long here. Initialize to 0. Does delta operate on 1 indexing or not? I'm not sure. We're gonna go 0 indexing. So in here, get line while. So basically at the end, but we have breaks out of the switch. At the end here, we need to say, hey, access sequence is being incremented. And there's no way to, so exit, that's fine. There's no way to break because these things are in a switch. That's fine. Okay, we're good. So we delete that. And then what we need to do is when we do our load, we'll say access sequence will be passed in here. And then same thing here. Okay. And then we'll go to our load and store. ACCESS sequence is a long, and that gets passed into here. And then that gets passed up here, long access sequence. Okay, so now we're in here. So what do we want to do with this? We want to pass it into our upsert line. And this is just for debugging. Okay. Okay. So in here, let's see. I have this prototype. And I want to set a breakpoint that fires when adder is equal to that and access sequence is greater than 3100. Upsert line if RSI is equal to that and RDX. Okay, sounds good to me. So here, now I'm going to say just make up, because I didn't have those things there yet. Okay, and then we're going to say csim here, but we're going to call gdb args here, and we're not going to output to test. We're going to run that. We're going to set our breakpoint here. And then we're going to restart. Yes. That's going to run through all the n number lines. Okay. It did not trigger my breakpoint. What is wrong with the breakpoint? If RSI is equal to, let's just put a breakpoint at upsert line, restart, and we'll disassemble this thing. So in here, it's making the assumption that RSI is that. So if you look for RSI, there's EDI. So this is a bunch of initialization stuff. And then we have this thing, we say auto I int is equal to 0. That's probably this guy here. Or it might be this one here. It's probably that one though. RSI. Well, let's go ahead and quit out of that. Print RSI. Print RDX. We'll just say continue. Print RDX 6. This is not the same registers that I would have hoped. So if we go back up to RDI, RSI, RDX, RDI is hex. If we look at our prototype, this set is a pointer. So that's just a pointer off into memory somewhere. That makes sense. Print RSI. But this is a immediate value type thing. So that's somewhere on the stack. No, it's an adder T. What is an adder T? Adder T is a struct. So we say here adder T is a struct, so it isn't passed in a register. If we print out RSI, that appears to be our sequence. To be so we say continue, print it out, yep. And if we go upsert line here, what we'll do is we'll just recompile this and we'll pass in the adder. So where's upsert line being called? Here. A. And then here we'll say uint 64 TA. Okay. And then we'll quit this. Yes. Make. Rerun it. Reset our conditional breakpoint. Which I did up here. No. Give me the original one. Yeah, this guy here. So that should work now. Restart. Yes. Hey, look at that. Okay. So layout split. Can we say next? So we're going to our loop. Say, hey, grab the line, the cache line. Can I scroll here? Yeah, I can scroll here. Did not match. Did not match. I don't think we have many lines here. If I print out S lines per set, there's only 4. So this would be 3, skip, skip. So now we're going to say, hey, is it going to be that we're already in missed territory? So why is that? Let's print out our lines. So if we print out S lines sub 0. Okay. Print out, can I say S lines? Print out S lines like this. How do I print out all the elements of an array in GDB? Can I select something here? No. Okay, we'll just manually do it. PS, or get some space here. S lines sub 0. PS lines sub 1. PS lines sub 2, PS lines sub 3. So they're all valid. They all have different use indices and different tags. If we print out our adder, does not match. We're in set 7, block 4. So we print out our adder itself. Sorry, print out A. Print out as hexadecimal A. So that is our adder. Just make sure we got the right adder here. I'm going to Control Z this delta between ref and, sorry, let me get back a directory. Delta between ref.txt and test.txt. So 574 EFE7F, yeah. So if you put this into a binary calculator type thing, We can use Python for that, right? Yeah, let's use Python. Python, we can say, hey, 0x this thing. We want the binary representation of that. And we called this whole thing with what arguments again? Fuck. Can I say, what can I say here? Print out, can I print out S? Print out S as a set, and let me get out of here. Let me control Z that. Can I tmux this? Let's tmux this thing. So over here I'll have my Python, and we'll do 0x. So 0x this, binary. Okay, so I have a binary representation there. And then I'm just going to take this thing and put some underscores here. 1, 2, 3, 4. So these are just nibbles. Oops. 1, 2, 3, 4, 5. Actually, yeah. 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4. There we go. Alright, and then over here in our bash lands, we're going to say jobs, no. Vim up our csym.c. And I want to see what the set has access to, because I have lost track of that. So we are in the upsert line, which gives us a set, adder parsed, adder unparsed, and our access sequence. So if you go to our set T here, we have lines per set. Should be 4. So if I print out S lines per set, it is indeed 4. We have 4 lines. Okay. Can I access in GDB, can I print out the args for the command that was run? I'm sure that is something GDB can do. Show args, okay. Show args. So it's 4 set bits and then 2 bits for the, well, that's irrelevant. 4 set bits, 4, so how big is this tag? Was it adder.tag? So print hex A, print hex adder.tag. Okay. So basically we have 64 bits minus our 4 bits for the block and minus our 4 bits for the set, which means we have 56 bits. And if we take this guy here and we say, hey, we want you to lose the right hand side 8 bits, that means we would do that. It would come out to this number. And if we do hex of underscore there, FE, 7 FE, FE05. Yeah, we just lost that last byte there. So the tag is correct. It just somehow the state leading up to that is incorrect. What's fascinating to me is that, like, okay, this is like line 3000 something, or line 3100 something of the trace that we're processing. And I wonder if you can simulate this delta without that huge build up to the trace. So I think the next thing I want to do, now that I've verified some of the execution of this, is to binary search my way to at what point is the difference introduced. So what we can do here is I'm going to copy cd into traces, copy our long to test.trace, and then if we hit Control D here, I don't need this right now, and we're going to rerun our delta. Actually, quit here, please. Just get out of here. Jobs. Okay, I'm going to run tmux under here as well. So whoa. Oh, this is the same tmux. Interesting. I didn't want to do that. So we'll hit Control D on that one. Actually, I'll just hit that. There we go. Control B that. No. Control B that. There we go. And then Control B space. I don't like this. Control B O. That did not work. Get over here, Control B, O. Did not work. Control B that. There we go. Okay. All right. So it doesn't matter. Fuck it. We wanted another window here. And we can split this guy, and then this guy is going to have our Python in case we need it. We got our history here. Okay, for our tag, let's go back to bash. What were we doing? We copied the trace, so we wanted to do our delta again. Delta, and it's line roughly 3115. So let's go ahead and run or vim up the traces test. We'll go to line 3115. We'll do 20 just to be safe. Delete all of that. And we're going to now do a rerun of this. So we're going to say csim output to test and csim ref output to ref. Redo our delta. It should just be 1. Wait a minute. What are we doing here? We don't oh, because we didn't fix the test here. It needs to be test. And this one needs to be test as well. Test. Alright, so to delta. Okay, great. Exactly what we wanted. Now let's try removing instructions from the top. So we're trying to narrow in on like the exact sequence of events that cause this thing to get messed up. So the first thing would be to do like a binary search here, but I'm just going to be a little bit optimistic and say it's recent. It's very recent. So let's do maybe line 3000 and delete from there up. So let's do rerun this. So csim and csim ref, and rerun our delta. There is no delta. Okay, it was not within 3000. Okay, so we need to restore that, rerun. What the fuck happened there? Rewrite. So we're gonna run our ref and we're gonna run our test, which is here. There we go. And then run our delta. Great. So let's go to line 1500 and delete from there. See if we could still reproduce it. That one, that one, that one. Still reproducible. Cool. So now there should be around 1500, 1600. Let's do line 800. Okay. So let's rerun. No delta. Interesting. That means that this thing's huge. Undo that. So maybe do like line 200. Oops, sorry, line 200 or 400. Let's delete that. Try it again. There we go, still works. Let's do another 200. So right now we're at what? 1200? Yeah, let's do 200. Oops. Okay, there we go. Still there. So now we're down to 1000. Let's do another 200. So it's about the time when we saw it stop. Still there. Alright, let's do a 100. Okay. Still there. That's weird. We're down to 700. Let's do another 100. Still there. Let's do 200. Still there. Let's do another 200. Not there. Back out of that. Alright. Okay, still there. So we're down to 420 lines. Let's try a 100 here. Okay. Not there. Okay. Let's back out of that. Restore it. Let's do 50 lines. Still there. Let's do 40 lines. Not there. Okay. Let's do 30 lines. not there. Let's back out of that. Let's validate that we can still generate this. There we go. 25 lines. Not there. Okay. Let's do 20 lines. Sorry. 20 lines. We'll do 15. Not there. Okay. Verify. Still there. Yep. Let's do 7 lines. Still there. Let's do 4 lines. Yeah, I think these loads are something we can remove. Oh, should be safe. What? The loads? Oh, because they populate the cache. Okay, the loads are needed. Which ones though? If I delete those. Okay. What if I delete that one? Not enough, okay. Okay, so we're down to a couple hundred, like 363. I want to do some analysis on this now. So I'm going to cat out that file. And I'm going to translate the comma to a space. And I'm going to use awk to select for print. That'll give me all the addresses, and I'm going to sort, and then I'm going to unique see it, and then sort that. I want to sort it numerically though. So there is quite a few addresses. What's interesting is that the most frequently accessed address is the one that we are inconsistent with the cache on. So 363 instructions or memory accesses is a little bit too much to manually debug. Like step through every single one, understand the state of the cache and all that. So what I'm looking to do here is to narrow down which memory accesses are significant and which ones aren't. Because I did my binary search down, so we have like an instruction up at the top is significant to produce the result that we see at the bottom. But there could be all these like filler instructions or filler memory accesses in between those two that aren't super relevant. So what I might try doing is just like eliminating chunks of the body of this to see if I can like maybe like not step on the hot buttons and still minimize the amount of data that we have to analyze here. And I did this just to see like which ones I could possibly eliminate, but I don't think this is going to be really helpful immediately. Maybe it would be helpful a few steps down the line here. So the first step will be to the foreground. Okay, vim up traces. Sorry, test. So maybe let's just try deleting like a bunch of stuff in the middle, maybe from like 40 to 60. that worked. So let's do 40 to 100. I'm looking to eliminate as much as possible here. That still works. Let's do that again. 40 to 100. No, that is needed. Okay. Okay. Let's do 20 to 40. How many sections do we have? So 200. So what we could do is like split it into chunks of 20, and that'd be 20. Chunks of 20 would be 14 different chunks that we'll have to analyze. I think that's doable. So this first one is obviously important. So if we delete this first chunk of 20, we don't get it anymore. So there's something important in that first chunk. Okay. Now, if we go from 20 to 40, delete that. Let's try that. Not important. Let's stay at 20 to 40. Important. So let's undo that. Rerun to make sure we have a clean test. And now we're going to go from 40 to 60. I really should be doing this like offset. So 40 to 59. Okay, that's not important. Next one, 40 to 59 again. Not important. Do it again. 40 to 59. Not important. 40 to 59 again. Okay, not important. 40 to 59 again. Not important. 40 to 59. That was important. Back out of it. Write it. Rerun. Okay. 40 to 59, so we're at 60 to 79. Not important. 60 to 79 again. Do it one more time. 60 to 79. Not important. 60 to 79. Not important. This one surely is important, right? I'd figured that the head and the tail would be important. Yeah, it's important. Okay. Okay. So we're down to 80. That's an improvement. If we rerun our analysis of which memory addresses are the most important, we're down to maybe 20 here? 20 something? 21? And most of them are the memory address that we care about. All right. So I think we should do something similar now where we just go to from 10 to 19. Not important. This one should be. So we'll skip that and do 20 to 29. Important, okay. Let's restore, back up. There we go. We'll do 30 to 39, which should be important. Oh, it's not. Okay. Let's do 10 to 19 then. Not important. Okay. Let's do this one. Should definitely, because we tested this already, right? Yeah, definitely important. Okay. Let's do 20. Well, let's validate it first that it reverted correctly. Just don't want to get too far off from reality here. All right, so 20 to 29. Oh, that's important. And then 30 to 39. That was important. Let's undo that. Okay. And then 40 to 49, I'm pretty sure is going to be important, but I'll test it just to be sure. Okay. So we're down to 50. It's quite a drop, especially from several thousand. We're now down to 19 memory accesses, different addresses. So the next thing to do would be go by 5s instead of by 10s. Okay, let's do that. So I'm gonna do by 4s, 1 to 4, 5 to 8. I think that'll be a little bit better here. Obviously those are important. 5 to 8. Not important. Let's do 5 to 8 here. This should be important. Yep. Restore. I'm going to make these 3 lines into one. So we'll do csim, ref, and then the delta. Okay, bam, one line now. So we just did 5 to 8, so we're doing 9 to 12. Not important. Let's do 9 to 12 again. Should be important. No? Okay. 9 to 12. This one should be important. No. Okay, we're making a lot of progress here. 9 to 12. No. Okay. 9 to 12. That one was important. Okay. Let's back out of that. 13 to 16. Okay, that one's important. Just verify we're still, yeah. So 17 to 20. Not important. 17 to 20. Not important. 17 to 20. Important. Okay. Okay. Down to 22 instruction, or 22 memory accesses, and 13 memory addresses. Still a bit too much for me to debug, so I'm going to do every 2 now. So 1 and 2. Obviously important. 3 and 4. Important. 5 and 6. Important. 7 and 8. Not important. 7, 8. This should be important. Yep. 9 and 10. Not important. This 9 and 10 should be important. Yep. 11 and 12. Not important. This one should be though. Yep. 13, 14. Not important, okay. And then of course those are the last one has to be. What? Okay, it's a different address. We're going from oh no. It kind of is a different address, isn't it? Did we change addresses here? So if we did this whole binary number without the shifting and did that as hex, it's 74. I don't really care what I'm debugging here, because as long as it's a bug, I want to narrow in on it. Okay, so now we're down to 12 instructions, 9 different memory addresses. Let's just do them one by one now. Okay. So the first one should be, yep. Second one, nope. Second one here, nope. Yeah, okay, that should be. Four. Let's back out of that, go to 5 next. Yep. Okay, 5 is needed. 6. 6 is needed. 7. Not needed. So these are just loads. 7. Okay, 7 is needed. 8? Is 8 needed? No. Okay, there's only 2 addresses. Or no, there's other bits that are changing in these addresses. Okay. So we're down to 7 lines and 5 addresses. Let's do that again. I want to see if I can minimize this even further to narrow in on a bug that we might be able to get to without even hitting every one of these. So that one's critical. That one is critical. It's line 3, critical. Let's just back out of that, make sure we can reproduce. Yep. Line 4. Critical. Line 5. Critical. Line 6. Critical. Line 7. Critical. Alright. So 7 loads on different memory addresses. And they got a hit and we got a miss. So that is the minimal reproduction of a bug. And if we run our analysis here, it's 5 different addresses, so not a lot. And 3 of them are around the address that is the delta here, which makes sense. At least 2 would be. Okay. So let me kill this. let me go to my calendar. I blew through my breakfast, so I'm going to move that to be at 8:45 now. So I am getting a little bit hungry here. So move that there. Just this event. And then this one will extend to 8:45. And we'll save that. This event only. And then this one is going to go from here to here. We'll say 9:45. 9:45 to, we'll say 12:30. Let's do maybe 1 p.m. Can I do 1 p.m. please? Thank you. And then we'll move our lunch cardio. Actually, no, we'll do 12:30 here. So 12:30. All right. And then lunch cardio will start at 12:30. Yes. And then afternoon, start at 12:30 and go to 5. All right. So I'm going to break for breakfast here. If I can get done with breakfast early, I will, and I'll rejoin. I think we're in a good spot here. We have a minimal reproduction test case of a bug, I should say. Doesn't necessarily mean it's our bug, but it seems very similar to the bug that we are seeing. It only, if I cat out traces test.trace and word count-l that, it's only 7 instructions, so we can literally step through every single one and see where we're going wrong. And it's only 5 different memory addresses. So I'm curious if we permute those memory addresses, if we set them to something totally different, would it have an effect on this bug or not? So these are all things that we can kind of like step through to continue to debug this issue. But yeah, I'm gonna go ahead and break for breakfast, and I'll be back in about an hour to continue working on this. Cool. All right, see ya.